So the first thing that we have is we have an IP address. That's the only thing we get given. We know in this case that the operating system is Windows. This is Resolute. And we have an IP address which is 10.10.10.169. What is that an IP address and how can we start to try to hack it, or what is happening here? So this IP address obviously is just an address that points us towards some place on the internet. So in this case, it's going to be a server. And in real life, you can kind of compare that to a house. So you have an address to a house. And if we are burglars and we want to break into a house, which obviously you shouldn't do, but in this thought process, let's say we want to break into a house, we need to find out where there are windows, which windows are open, which doors are open, and stuff like that. And that's going to be the first part in our enumeration here. We are going to find open ports. And in order to do that, the easiest way is to use Nmap. Nmap is a great tool that can help us with scanning for open ports. So let's see here, we are going to run Nmap with the -p- option. Now -p stands for ports, so which ports are we going to scan? And in this case, we scan ports, which is all of them. So there's over 65,000 ports, and we want to scan all of them because we want to know all the places that this server can interact with us. And that is what a port is. A port is on the OC level, on layer 4, is a place for us to interact with a server, or it doesn't have to be us. It's a place for anybody or anything or any servers or any other computer to interact with that server in a specific way. So we are going to scan all those ports because we want to know all the open ways or all the ways that we can interact with the server. Then we supply the -t4 option. So the -t4 option is going to kind of set the speed and performance that Nmap is going to use. The number ranges from 1, very slow, to 5, very fast. And if you're running Nmap, you can kind of change this depending on how reliable your network is. So if you're on a very speedy network to the server, you can put it on 5. If you see that some requests are dropping, then you can lower it to kind of match that and make sure that you're running it correctly. So that's what -t4 is doing. Then we have -A, and -A is pretty much going to tell Nmap to run everything. So that includes operating system detection. It's going to use scripts that Nmap has on the open ports. It's going to do a trace route and so much more stuff. And I just like to use this option. Definitely on a lab where I don't have to worry about being noisy. I just like to get all of the information that I can get, because any information can be useful, you know. So the more information you have, the better. So let's use -A. -V just stands for verbose, so it's going to output the open ports it finds directly to us instead of waiting for a report at the end, but you can leave this option out. And then we have the IP address. So if you run that, that will take a little while. So I've obviously already run that for us. So in my output /nmap, here we have the results. So let's scroll all the way up here and see what happened. So it started scanning 65,535 ports. Then it's found open ports and reported those to us. It started some scanning, and it gives us a nice overview of all the open ports. Now I'm gonna go over these really quickly. So 53 is DNS, domain name service. 88 is Kerberos. Kerberos, when you see that, you have to start thinking, is this an Active Directory domain? Because Kerberos is an Active Directory, it's a place or a way where you can kind of authenticate with the network to be able to do things. So you're going to authenticate with Kerberos with a username and a password. A Kerberos is going to give you a ticket, and with that ticket, you can then go to different services on the network and use them. So that is what Kerberos is. We then have at 135, we have RPC here, MSRPC. RPC standing for Remote Procedure Call. And this is something that Windows uses for computers to communicate with each other without having to know how the network is set up. So this is only really for computers, and it actually doesn't use port 135, but it uses SMB. So SMB is port 139 and 445. And it uses that to set up a connection and is then going to use other ports. So if I scroll all the way to the bottom here, you can see a lot of RPC ports, and these are all set up over SMB. So yeah, then we move to SMB. SMB, we all know it, we've all heard of it. You have shares. So that's something that I won't go into deep here. We'll then also have LDAP and some other ports. 5985 is also one to take into account, which is WinRM. So that's a Windows remote management, I think. So and this is a very popular port for when you have credentials to get a shell, because it allows you to get a PowerShell shell. So that's really all the interesting ports that are open here. And now that we have all of that information, where do we go? We have our house, we know where all the open windows are. Now we have to see which ones do we fit through. And all of these ports are interesting to check out. However, some are more interesting and some are less interesting. So if I look at all of these ports, there are 4 that really stand out that I want to check. First of all, there is, let's start with WinRM. So WinRM 5985, that port is interesting because obviously you can get a PowerShell shell. However, currently we do not have any information, and we need a username and password to get a shell, obviously. If we had usernames, we could try to brute force, but we don't even have usernames. So currently, that's not really a thing I want to check out. What's next? We have LDAP, we have RPC, and we have SMB. Those 3 are interesting because they might allow unauthenticated access, and we might be able to enumerate some more information with that. So in this case here, I want to start with looking at RPC. RPC, like I explained, is a way for computers to communicate with each other and share information with each other. But obviously, if computers can use it, we can use it as well. And there is this really useful command for it, which is RPC client. Now, we can do manual enumeration, and that's what I will be focusing on here, to do things manually. Obviously, there are great scripts that will help you do a lot of this enumeration automatically. However, I find that when learning, these scripts are useful, they will give you the answer, but you don't know what's going on behind there. So, for example, in this case, if you want to scan SMB and RPC, you can use the enum for Linux command, which works greatly. But yeah, we are going to try to do it manually. So using RPC client, we can try to make a connection here. So currently we do not have any username yet. So I'm just going to supply -u for username, and I'm going to say, okay, empty username, because I don't know any username. So I want to log in as the unauthenticated user, the anonymous user. And I also don't have a password, so I'm going to supply the --no pass option. Then I'm just going to supply the IP address here, 10.10.10.169. And when we try to connect, we see that we do get a connection here, and we do get a shell here, an RPC client shell, where we have a lot of commands that we can run. Now, that seems weird. Like, is it on any Windows system? Are you allowed to just run commands using RPC? No, you are not. So this is a misconfiguration here. By default, this is not possible. However, a long time ago, back before I was even born, it was this way by default, but they changed that. However, Windows always has a very big issue with backwards compatibility. So due to backwards compatibility reasons, sometimes the anonymous user is in a backwards compatibility group, and that allows it to still be able to do this. So this is a misconfiguration. However, it is easy to just oversee that is possible as a sysadmin. So it's a misconfiguration that does occur quite often. However, we have found it, so we can try to attack it. So let's take a look at all of these commands. And there are a lot of them, like so many, and we cannot execute all of them. So for example, for some reason, if I wanted to get printer info, let's try to run get printer, and we see that we get an NT status access denied. So we don't have access to this. So we do not have access to all of the commands. However, there are some that are very interesting that we might have access to. Currently, we do not know anything about the network. We know the open ports, but we don't know what users are available. So a command like, let's see here, enum dom users, enumerate the domain users, would be extremely interesting to run, obviously. So let's see if we can do that. So enum dom users. that works, and that gives us a long list of names here. So now we know that all of these names are users on this machine, some of which we already expected, like administrator, obviously that is a user. However, in French systems, this name might be different, so you don't know that for sure, but I mean, this user, you expect that. But then we have all of these names that we obviously didn't expect. So already we have way more information. Now, there is also this command called query user. And with query user, we can request more information on a specific user. So let's say I want more information on Fred. I want to know what he's up to. So let's see what happens here. We get a lot of information. However, a lot of them aren't filled out, so there's no comment for Fred. We see that the last logon time for Fred was the 1st of January in 1970, which clearly isn't correct. And you may be already able to guess why it's this date. If you know about epoch time, so in epoch time, it's seconds since this date. So probably for the logon time, Windows is storing the epoch time of the last login, and this is going to be 0, so that's why it's this date. However, it's obviously not that interesting for us. But yeah, we can obviously get all of this information on all of the users, which is going to take a little while. But luckily, there's also the command query disp info, and that is going to show us all info of all the users, but just like a little summarized version. So not all of the fields, but some of the interesting ones, such as the description, for example. For administrator, the description is built-in account for administering the computer/domain. Here we have the default account, a user account managed by the system. We also have the guest account, built-in account for guest access to the computer/domain, some more. And then we have Marco. Marco has a description set, and the description is account created, password set to welcome123 exclamation point. So that's very strange. We seem to have found a password here in a very odd location. But let's think about this and why this would be the case. So an Active Directory domain most often is of a company. So let's say this is a company and the sysadmins need to make accounts for new employees. So Marco joins the company and the sysadmins get a ticket that says, okay, make a new account for him. They are most often going to set a default password, just a password that they use for the first login of Marco. And then password policy, or the policy within the company, is going to be that you need to change your password the first time you log in. However, maybe Marco forgot to do that. So let's try that out. Let's see if we can log in with welcome123 as Marco. So for that, I am going to try that out. So let's see. We can use SMB client here. We have a username now. We have the username Marco. And then we also have the share. So I'm going to try to log in over SMB now, just because that's very easy with SMB client. And then we supply the share. So that's going to be the IP, 10.10.169. And then we supply a share. So I'm going to use the IPC share here because I know that share exists on every system. And then we can see we have to enter the password here. If we enter welcome123, does that work? No, that does not work. We get a login failure. So it seemed that Marco has potentially already removed his password, changed it to something else. So yeah, that's a bummer because we cannot get in that way. However, the sysadmins use this password as the initial password for Marco. But what if they do that for every user? For everybody that joins the company, they set that password. What are the odds that one of these users is not going to have changed their password to something different? And password policy is, if it's not enforced like directly, it can definitely, people forget, people say, oh, my password is not important. So that's a thing that actually happens. So right now, what I am thinking of doing is taking all of these users and trying that password on all of them. So a sort of brute force, but it's not really a brute force because we have enough information to say, well, it's very feasible that this exists, and we are only going to try one password on all of the users. So this is kind of a password spraying. We spray this one password on all of the users. So for that, we obviously need a list of all of these users. So let's see how we can get a list. So we have this command here. I'm going to put that command in a file. So for that, I'm just going to use RPC client again. But this time I'm going to say, okay, run this command and then store it into a file. So I've done that. And if I cat output /RPC client, we see we have that command. Now we want to take out all of these usernames, and you can do it very easy by hand. These are only 20 or so you can easily copy paste them in a file. But imagine that there are 200, 300, which you really want to do it manually. No. So let's use some bash magic and do this automatically. And for that, we're going to use AWK, which is a really difficult tool that you can use and do simple things with, but also very, very complex things with. But let's just use it in a simple way here. So we're going to say, okay, pipe that to AWK, and then I'm going to set a field separator. A field separator is going to say, okay, split every line that you have, split it on a certain string. So in this case, I'll set the field separator to be account : space. So we're going to split on account, and that leaves us with this part at the beginning and the name followed by this at the end. So what am I going to do with that split? I'm going to print out the second part. So let's print the second part here and see what that leaves us with. So that leaves us with the name followed by this stuff at the end that we don't need. So let's just pipe that to AWK again, use the field separator again, and split it on an empty string. Split that on an empty string, and then we want to print the first part. So printing out the first part leaves us with all of the names, and that is what I have in the users file here. So now we have all the names and we have the password that we think one of these users might still be using. So let's go ahead and do a crack map exec on this. So crack map exec is a great tool for brute forcing or password spraying or any of those things. So let's just jump straight into it with crack map exec. And I'm going to try to try these passwords on SMB. Why SMB? We could also use WinRM. Well, SMB is quite fast, so that's why I like to use it. So let's just try it out. So SMB with the IP address, so 10.10.10.169. Then we're going to supply the users file. So this is the file that contains all of the users, and then the password, which is going to be welcome123 exclamation point. I then also set -- continue on success, which is just going to ensure that after it finds a valid login, it's just going to continue and do all of the users. I think in this case, it's very important because there are chances that 2 users might have forgotten this. And in that case, you obviously don't want to stop at the first one because you want to find everything here. So for all of these users, we see status logon failure. So that failed. However, Melanie, oh Melanie, you forgot to change your password, which is not good. Well, good for us, not good for Melanie, because now we know that we can log in using SMB as Melanie. However, next to this output, we do not see the pond text. So if you've been using crackmap exec for a while, you will notice that oftentimes when you find a valid credential, it will say pond next to it. And what that means is that is crackmap exec saying, hey, with this credential, you can get a shell, you can get code execution. However, with this credential and SMB, we cannot get code execution. Well, okay, this credential is still correct for SMB. What are the odds of Melanie also being able to log into WinRM using this credential? So let's also crackmap exec for WinRM, and let's only check for Melanie in this case. So let's see here, and this time, yes, Melanie, and welcome123 exclamation point, and it says pound, so that means that we can get a shell as Melanie here. Okay, that's really cool. That's great. Let's do that. So WinRM is used for remote management, so it allows remote sessions, and And from your Kali, the easiest tool, and I think this tool is so amazing and so underestimated, it's Evil WinRM. So Evil WinRM, we're gonna use that. I'm gonna set -I to be the IP address. And then we're gonna say for the user, Melanie, use the password welcome123 exclamation point. And if we do that, we see that this gives us a PowerShell, and we now have access as Melanie. Great. Now, before we move on, I quickly want to do a bit of post-exploitation checking. So if I do a whoami/all, this is also going to show the groups that Melanie is a part of. And one of these groups here is the pre-Windows 2000 compatible access group. And this is most likely also the group that allowed us anonymous access to RPC, which allowed this whole snowball to start rolling and us to get code execution as Melanie. So right now we've reached Melanie. I'm now going to take a second to answer some questions, take a short break for you guys to get caught up doing this by yourself and trying it out on the machine that you have available. So yeah, let's get into that. All right, so we've just gained access to Melanie, and now starts enumeration all over again. So right now you have command execution on a Windows box, and there's a lot of things that can be wrong. There can be credentials somewhere, for example, just a crazy example, somebody used Firefox and saved some passwords and you can decode those passwords. There might be services that you have access to that you shouldn't have. So there's a lot of things to check here, and a lot of automated tools can do that for you. So I'm talking about the WinPiece, the seatbelt, other stuff like that. And I really recommend using those tools to enumerate everything. However, in this case, I'm not going to be running these tools because obviously it would just, all these tools do is they have their checklist of things that they are going to check and they'll check it. And the issue that I have with that is it shows all the information, that's great, but it doesn't show how it got this information. So for example, if it finds a service that is vulnerable, how did it find it? What did it scan to do it? So instead of just running through that output, I'm going to pick a thing and I'm going to test it out manually just to see how you could also manually find it with your own checklist. So one of the things that you always have to check in when you're doing a Windows box is PowerShell. Why? PowerShell, obviously, users can use it to type in commandlets, to do a lot of stuff. And PowerShell has the chance to save a transcript. A transcript is just a list of all of the commands that were ran in a session, so just a command history really. And the command history is created with the start transcript commandlet. So with that commandlet, if I show the help here, oh well, it started the transcript now, so there's no -- help here in this case. But that's fine, but start transcript is going to start the transcription and it's going to save everything you type to a certain file. Now, what file is it going to save everything to? That is set in the registry. So in Windows, you have the registry, which contains a lot of values, and being able to query the registry and look around in there and see what values are available is very useful. Now, in this case, the URL or the location of the registry, you do not need to remember it by heart. Obviously, the tools are useful and cheat sheets are useful, so use them to find the proper URL for looking at the PowerShell registry. But in this case, I'm just going to type it out here. So what we are looking at here is we're going to do a GCI, which is get child item. So we're going to get the child item off a certain path. And that path in this case is going to be HKLM, so that's the registry. And then we're looking into software, wow, 6432 note, I think, /policies / Microsoft/Windows, and then /PowerShell. And if we query that, we see a a couple of names, and then the values for these properties. So first of all, module logging, script block logging, and then we have transcription. So enable transcription seems to be disabled right now. However, the output directory here is set to CPS transcripts. So CPS transcripts, this is the directory that when you start your transcription, the values, the logs will go to. So let's check that out. So let's cd // and do a dir here. Oh, there is no CPS transcripts. Or is there? Well, let's check that out, because right now, if you were to convert this dir command to Linux, because a lot of you like Linux, you've just learned, it will be just an ls. And ls is going to list the files. However, there are hidden files. In Linux, you would type ls-l-a. However, in this case, that doesn't work. So we have to do dir-hidden, and that's going to show us hidden files. You can also do dir-force, which will show you even more information. But in here, you can see PS transcripts. So these are all the transcripts are stored here, and this is how you can find this directory. Now, I know that a lot of people, when they first solved this box, they actually, or when people asked for hints, the hint would be, yeah, just look for hidden files. And I think that is the wrong way of going about this, because searching for hidden files, obviously, there's no real path that you're pursuing there. However, in this case, we first looked at, okay, we know PowerShell has this transcription feature. Was a directory set, and are any transcripts stored in there? And that's how we got to this location and how we found out about this. So let's move on with this and look at this directory. What is in there? So I'm going to do a dir of PS transcripts, and it is empty, or is it? Obviously, you know that it won't be, so with -hidden, we will find out that there is another directory there. So looking into that, we now found out there is a file, so it doesn't start with D here. And this file is a PowerShell transcript on the RESOLUTE box, so it contains the host name here, and then it contains the date of it. So that's 2019, the 12th of March, I believe. And we can now read this file. So now instead of doing a dir, we use type here, and that will output the file to our screen here. We can scroll all the way up and take a look at this file. So first of all, it contains some information here about the transcription. So the versions of PowerShell, all of that kind of stuff. We see that the user that ran this is Ryan. So that's a different user than we are right now. And Ryan is running some commands. So let's see here. It starts with a system error, it seems, on a invoke expression. That seems to be wrong. So it's -join. There's a who am I. And this seems to just show just the PowerShell, how do you call it, the prompt at the front of it. So it's PS who am I at the computer name. And in the second command here, we see that the outstring is PS Megabank Ryan Resolute in the documents directory. So that's what that is. But then moving on, we have a different invoke expression, and this time we're doing a cmd/c. So we're running using cmd.exe, running a command, and the command is net use --fs01/backups as the user Ryan with the password server admin access 123. So what is this command doing? So net use, we are trying to mount this SMB share fs01/backups, and we're trying to mount it to the X drive. And obviously, when you are using SMB, you can have a password and a username, so that's what is supplied here. So Ryan was trying to use SMB with this this password. So one of the things I'm wondering here is fs01, can we resolve this to an IP address to potentially find a new box? So in Hack the Box, you often only have one IP address, so that won't be a thing here. But in a real-life engagement, obviously this might lead you to some other place, and then maybe you can mount that share from there. So let's try to do it with ns lookup. So using ns lookup, we can say fs01 and see what that resolves to. And we have to wait a second here. And it times out. Well, that's strange. DNS isn't supposed to time out. But looking at the address here, it uses 8.8.8.8, which is the DNS of Google. Hack the Bug boxes don't have access to the internet, so obviously it cannot go to Google DNS to ask, hey, is FS01 something? But we saw earlier that a DNS server was running locally here, so maybe we can use that. And in NS lookup, you can just supply the DNS server to use as the second argument. So doing that, we see that it cannot find FS01, it's a non-existent domain. So it has no idea about this, so that was a rabbit hole that we quickly went down. But let's go back to the command, because we obviously still had some information. We had Ryan and this password. So this password originally is for this SMB share, but password reusage is a big thing here, everywhere really. So if you find a password, try it out in different places. What would be a good place to test it out? Well, obviously WinRM, because if that would work, that would instantly give us a shell as Ryan, which would be just amazing. So let's check that out. So I'm gonna exit out of here and get a new evil WinRM going, this time as Ryan. So pasting in his password, we notice that, yes, we do get a connection here, which is just amazing, because now we have moved on in a way. We don't know how yet. We don't know if we moved closer to an account with more privileges or an account with less privileges. So we don't know if we move vertically or just horizontally. That's really, we don't know that, and you never really know that when you're doing lateral movement. In most cases on Hack the Box boxes, it will be that when you find a new account and you get access, that is a positive move. So you're moving to an account with more permissions, but in real life, you never really know that, because you could always just move down to an account with less permissions. However, that's a good thing to keep in mind, that finding a password and finding a new user isn't always the positive breakthrough that you needed to keep your feet on the ground. However, now we are Ryan, and I believe we have another break lined up here for you to catch up with me to get access as Ryan, and if there are any questions, I will answer them as well. Is that okay? Perfect. So currently we are the user Ryan, and again, we have a new user, so a new place. This user might have access to new things that we didn't have access to earlier. So again, restart all of your enumeration. Run WinPiece again, see what output it gives. Now, one of the things that WinPiece is obviously going to show are your groups. Now, what are groups? How can you see them? So from typing whoami/all, you will see a list of all of the privileges you have, but also all of the groups that you're a part of. And groups are pretty much just a group allows certain things, and if you're in that group, you are allowed to do those things. Now, looking at these, there seem to be a bit more than we had with Melanie first. So let's look over them. So we have built-in users, those 2000 compatible access. We have remote management users, and it's people of this group that are allowed to use WinRM. So if you're not part of this group, you cannot use WinRM, I believe. You have authenticated users, this organization. Then we have contractors here, which Melanie wasn't a part of. And then we have DNS admins here. Now, DNS admins is very, very, very interesting. Why is that? Well, the name says admins in it. So obviously this already seems to be a step up from what we had with Melanie. So if you were to search this and find out what Microsoft has to say about this group, then Microsoft will tell you that members of the DNS admins group have access to network DNS information. And Microsoft is hugely understating the impact that giving a user DNS admins rights has. Because when you give a user DNS admins rights, you pretty much are just giving them a domain admin at that point. Because the DNS service is running as system. And DNS admins are allowed to really do anything with that service. So they are allowed to change certain values and do a lot of things with them. And using that, we can get command execution as system. So I really do not like how Microsoft states that on their documentation. I couldn't find any notice of, hey, be careful with giving this group to users. So this is a fully, I guess, accepted risk. But yeah, this happens a lot therefore. So people don't know that this is an issue. But we have this issue and we want to exploit it, obviously. So let's see if we can get some code execution as system through being a DNS admin. Now, how do DNS admins, how do they play around with the DNS service? There is a commandlet, which is DNS CMD. And this commandlet is used for managing DNS servers. And there's a lot of things you can do here. I'm doing dash. That's what I did wrong earlier with the start transcripting, because that's Linux, but I should be doing /help here to show the help. Okay, so that's going to show us all of the commands that you can execute here. And you can see this commandlet allows a lot of setting things, doing things with the DNS. And there's one thing that we are interested in here, and that's the configuration of the DNS. Why is that? Well, through the configuration, we can set certain values for the DNS in the registry. We can, for example, set the server level plugin DLL. And that's a whole mouthful, but what that pretty much means is it specifies the path of a custom plugin. So when DNS is started, you have the opportunity of having plugins. So a white hat use of this is also like an intended use of this would be to have some extra functionality when you start your DNS server. But obviously we can use that to start any DLL. And that's what we are going to be doing. So let's use DNS CMD. The help also says that at the first argument needs to be the server name. The DNS server is running on localhost, so that will be the server name in this case. Then we say, okay, I want to set the config, and I want to set the /config, and I want to set the server level plugin DLL. And here we can set the DLL to a certain path. So if it was in this path, let's say we just use something.dll. Obviously that doesn't exist at this point, but that's fine. We have just set the registry property server level plugin DLL. And now, like I explained earlier, when we start the DNS service, this DLL will be run. And how can you start or stop a service? That's with sc.exe. We can first, obviously, if you try to start a service now, we will notice that it will fail because the service is already running. So I'm gonna stop the service first, and then I'm gonna sc.exe start DNS. And that will restart DNS. However, in this case, our something.dll does not exist. But technically, we've just talked about it. If we were to create a malicious DLL, we would be able to start the DNS service and run that DLL. So what is stopping us from creating a DLL? So let's go right ahead and do that just now. For creating a DLL, the simplest way here is to use MSF Venom here. So that's a Metasploit utility for generating payloads. So MSF Venom followed by -p. Now we're supplying the type of payload that we want to generate. So we want to generate a payload for Windows for 64-bit. I want to create a shell reverse TCP. So this is going to just connect back to our machine. And now we supply the L host. So that's the IP address of our machine, which is 10.10.14.3. And then the L port. And for this, you can use any port. I like to use 5555 on boxes, but sometimes ports are being blocked or something. So if for some reason your reverse TCP shell isn't working, you can try to use ports that connections to are not being blocked. So for example, DNS. So that's a quick trick. If something is going wrong, test that out. But then with the -f argument, we supply the type of file that we want to generate. Now in this case, that's a DLL. So we're going to say -f DLL, and then with -o, we supply the output file, which will be ref.dll. We run that, can take a couple of seconds to run, and now we have our DLL here. If we do file ref.dll, we see that this is indeed a DLL for Microsoft Windows. Cool. Now, we need to set the DLL in this command, in the dns-cmd command. One thing we can do is upload this DLL to the box. The big issue with that is that most Windows machines run antivirus software, so an AV, which can be Microsoft Defender or another one, and payloads generated by MSF Venom are almost always going to be flagged. So that's not really the best idea. Because once this file touches disk, antivirus is going to pick it up and it's going to say, no, we're not going to be using that. However, in Windows, when you don't want to run things off disk, and I do this with any kind of payload that I want to use on Windows, I use SMB, because if we supply // then our IP address, which was 10.10.4.3, then a share, which I'll be calling pink, and ref.dll. Now, Windows is going to go to my share that I will obviously still have to set up because my machine currently isn't being an SMB server, but I'll set that up. It's going to grab this file and run it without the file ever touching disk. And I use it in every case. Why? Because it also makes cleanup easier. When you're doing an engagement, you obviously don't want to leave anything behind. You want to clean up after yourself as good as possible. And having your files not actually go to disk is a great way of cleaning up already, because you're not leaving anything behind, right? So just also for that, and also to bypass that disk scanning AV, I always like to use it, and really in any case, try to use it. Also, for example, if you have a remote file inclusion on a Windows box, or a local file inclusion, try to use it, see if you can expand it to a remote file inclusion. So always think about SMB in Windows, because it will help you a lot in a lot of boxes and in a lot of real life engagements as well. But okay, we have the IDE here, we have created our file, now we just need to host it. So for that, I'm going to be using inpacket SMB server. The first argument is going to be the name of the share. And then the dot here is the current directory. I want to expose this current directory with the files of it as the SMB share. So you can really simply set up an SMB server this way. It's super easy. And now it's running, and that's all we need. So now everything should be ready to go. One thing I forget is the listener, because obviously we are going to be setting up a reverse shell here. So I want a listener, so I'll use rlrep netcat lmvp 5555. So rlrep in this case is going to make sure that I can still use my up and down keys to bring back previous commands. So that's just a nice wrapper that I always use around netcat. Netcat is going to listen. This is verbose, P is port. N, I think, means it's not going to do DNS lookups, but I believe you can just leave that out as well. But I always just remember L and VP. So if I run that, it'll start listening on port 555 on my machine here for connections. Now, I set this value, and now I restart the DNS server. Let's see if something happens here. And immediately we see that we have some issue because no file was received from my DNS server. Let's see what is going wrong here. So, is this still my IP address? Yes, it seems like it. Okay, ref.dll is the file. And that is going wrong. Okay, if I just enter this, will I get this file here? The network path was not found. Okay, interesting. So something is clearly going wrong here. Let's check my VPN to see what my, or let's use ifconfig. Yeah, on my ton 0 interface here to see what the IP address is. So 10.10.4.3. Oh, 10.10.14.3. That was my issue. So normally if I use 10.10.14.3 here, did I use it correctly in my payload here? Oh, I did. So yeah, my fault. Mistakes were made, but now, whoa, that was the wrong command. Can I have my shell back, please? Let's see here. Okay, so WinRM errored out. Let's just start over again. So DNS CMD, my apologies for this little detour. I'll copy that and I'll paste that, and then I'll copy the command that will restart the DNS service. I'll run this one and then restart the DNS service, and now we get a connection back here. So we see that the file was received from SMB, the service was restarted, and now we have a shell. If we do a who am I here, we see that we are system now, so we have found this machine, which is amazing. However, what happened here? The DNS service tried to run my DLL. My DLL was run and it works, but my DLL never quit running. So right now the DNS service is down, so no DNS is working, and we can validate that by doing an NS lookup of a non-existent domain. So ping draconian is cool, nobody has ever thought that, so that domain will definitely not exist. When we run that, that will time out. Yes, but I used the DNS of Google, so that will not work, so I'll use the local DNS here. And that should also time out because the DNS service is not up, because it's still doing my reverse shell here. So if I quit this now, so now the DNS service will start to go up, and now we see that no response from the server. So yeah, we got code execution, but we took down the DNS. In a lab environment, that's not a big deal, that's all right. However, in real life, when you're doing a real engagement, definitely in a pen test, if you bring down the DNS, those people the sysadmins are not going to be happy, because you don't know what's happening there, you don't know how important that is, and just bringing it down for yeah, that's not good. So you need to make sure that the DNS still runs, else you're going to get some angry messages back. And if you're not doing an engagement, if you, let's say you were a malicious actor, obviously you also have reason to make sure that the DNS stays up, because if the DNS goes down, there's a big chance that alarm clocks are going to go off, and people are going to be alerted of your acting, and you don't want that. So after the break that's coming up right now, we will really quickly cover how to do that. But I will leave that also a bit open to you, so I'll just show how I did it, and then leave that open to you to play around with. After that, we'll do the quiz, and then you have some time to play around with it as well. Quick recap, we were able to get system as the Ryan user through this DNS admin approach. However, the DLL that we created with Metasploit, it broke the DNS. So while our reverse shell was present, the DNS server wouldn't work, which is something that we don't want. Now let's think about why that wouldn't work. Obviously, this DNS plugin that we are setting expects current values. It expects some place to hook into and run code from as a plugin. And we obviously don't have that. We just created a generic DLL that will be a reverse shell. So in my hunt to find a way of doing this, I found this post here, which kind of talks about how to do it. And they reference here this DNS exe persistence. Now what is this? This is a sample plugin DLL for a Windows DNS server, for the server level plugin DLL. And that's exactly what we need. So I cloned this repository, and this is C++. And then we have this present here, so I'll open this in GitHub first. And before I go ahead, I do not know how to code in C++. I do not know how to code in C. I know a lot of higher level languages, but I never got interested in that kind of stuff, and that is okay. You don't need to be a guru in C or C++ to do Windows stuff, so don't get scared of it. If you know higher level languages, this will all come quite easily. So first of all, let's see here. So this C++ file, it does some linking here, and it links, for example, the DNS plugin initialize, which is obviously the function that is called, or this is run when the DNS plugin is initialized. We then also have a query and a cleanup here. But for our case, when this plugin is initialized, that's when we are going to be running our malicious code. Now, this function is going to be called, and it's going to run something. When we're running that, we're blocking the thread. So you have to imagine you're running code, so you're going from the top. So the DNS service, it starts this plugin, the initialize is called. Let's say we start a reverse shell there. It is going to stay in a reverse shell, and it's never going to continue with initializing DNS while in that same thread. So what do we want to do in that case? We want to say, okay, let's start a separate thread so that when it initializes the plugin, it starts this new thread, which can do a reverse shell running here, but then it can still continue with initializing DNS and setting up the DNS server. So that's what I did here. So I used this DNS-exe persistence. I modified it here, this DNS plugin initialize, to start a new thread. Now I just copied this code from online and just searched how to make a new thread and copied that because, like I said, I don't know C++, I don't really know how that works. But what is this new thread going to run? It's going to run my code execution function. So I defined that in a header file here. So it's going to start that and go into here. Now, in here you can do a couple of things. So for example, the simplest thing is to just run a system command and then return. But we could also just set up a reverse shell in C++. Now this code all looks terribly difficult, and as you might expect, I did not write that. I just googled C++ reverse shell, and then this custom C++ reverse shell proof of concept came along, and this code seemed easy to just copy and paste into my file here. So that's all that I did. I changed the remote address and the remote port, and then I built a solution. Load the DLL that is then in my release file, load it up on my virtual machine, my Kali machine. So now I have that here. So if I do an ls of ref-star, so it's the ref-working.dll is that DLL that I just created that has that separate thread. So let's see if we can get that working. We still have our SMB server running here. I'm going to set up my netcat listener. And now I'm going to rerun this DNS-CMD. So exactly the same as before, we are going to load a DLL, or in this case here with this command, we're going to set the server level plugin DLL in the registry to be ref-working.dll. Okay. And we just restart the DNS service. We see some connection was made, and we get a shell here. So we are again system. And now the moment of truth, did we manage to actually have the DNS server working at the same time? And we see localhost can't find ping draconian is cool, it's a non-existent domain. We didn't time out, so it was able to try and see if try to resolve this name. So the DNS server is up and running, and we were able to get domain admin, to get code execution as system without really breaking anything, without hopefully not alarming any, getting some alarm clocks to go running. And yeah, that is that approach. I know I showed this really quickly, but play around with that. And definitely, if you can code in C++, definitely play around with it, see what you can do with that, and enjoy, I would say.